Hello, we're going to find the relationship between the product and the reactant through the mole concept by considerations that are part of stoichiometry. Our question here is calculate the volume of oxygen gas produced at STP when 12.25 grams of potassium chlorate are decomposed completely by heating according to the question below. As the question here we have in the part of question here we have 2 potassium chlorate, we have 2 potassium chloride and 3 oxygen gas. So we have 2 product, that is potassium chloride and the oxygen gas, and the reactant, that is 1. So this is the decomposition reactions. So from that, now we're going to correct our data since the question we have given already. So from this balanced chemical equation that is potassium chlorate that is decomposed to form 2 potassium chloride plus and 3 oxygen gas. So this gas, this one is salt and this is salt. So from that, from the question that we have given is to find the volume of oxygen gas produced at STP. So from that, the volume here in a part of oxygen, we find the volume we haven't, but in a part of potassium chromate we have the mass. The mass is 12.25 grams. So from this information that I have given now, we must find the number of moles that we are going to relate. By looking this direct, we can start with the potassium chlorate by finding the molar mass and the mass. Since here we will find the molar mass, so right back on the part of potassium chlorate. So it will be potassium chlorate have mass of 12.25 grams. This is mass, and the molar mass it will be this potassium have 39 plus the bracket, chlorine is 35.5 plus, for oxygen is 16. So there are 3 oxygen with times 3 into bracket, but there is a unit is gram per mole. So at the end, when we plug into our calculator, it will be the molar mass of potassium chromate. It will be 39 plus 35.5 plus bracket 16 times 3 the bracket. The answer is equal to 102.5 grams per mole. So this is the molar mass of potassium chlorate. So the purpose of finding data is to come to this formula that number of mole of potassium chlorate, it will be equal to mass in a gram divided by molar mass. That's it, gram per mole. You see. So from that, it will be number of moles of potassium chlorate is equal to the mass that I have given. It was 12.25 grams divided by the molar mass that I have given. It was that I will find is 120 22.5 gram per mole. So gram with gram will cancel out, so at the end we will remain with the moles. So at the end it will be a number of moles is equal to 0.1 mole when you plug into your calculator. So it means that the number of moles of potassium chlorate, it was 0.1 moles. So from that now, if we have already obtained this, we're going to the stoichiometric coefficient as from the balanced chemical equation that we have 2 moles of potassium chlorate and 3 moles of oxygen gas. Since we're going to find the volume of oxygen gas, so it will be 2 moles of potassium chlorate. It will be equivalent to 3 moles of oxygen gas at the balanced chemical equations. Therefore, if you have already obtained the number of moles of potassium chlorate from the mass that we have given, that is 0.1 moles, it will be equivalent to how many moles of oxygen gas? So we close multiplication. So after closing the multiplication here, we will obtain the answer, that is number of mole of oxygen gas is equal to 0.1 mole times 3 moles divided by 2 moles. So then the 1 mole will cancel with mole, so it will be 0.1 times 3 divided by 2. So it will be 0.1 times 3 divided by 2. It will be number of mole now. So number of mole of oxygen gas is equal to 0.15 moles. So we have already obtained the number of moles in relation to the mass of potassium chlorate. So we can say that that is 12.25 gram per mole. Gram is equivalent or is proportional to 0.15 moles of oxygen gas. You see? So from this relation direct, we can back onto the thing we call STP, at standard temperature and pressure. So we're going to find the volume of oxygen gas at STP. So by finding the volume of oxygen at STP, it will be, we know that at STP, any gas 1 mole is directly proportional or is equal to 22.4 decimeter cubic. So 1 mole of oxygen gas is equal to 22.4 decimeter cubic. So the most of oxygen that we have already obtained from the calculation, that is 0.15 moles, it will be equal to how many volume at STP. So we close multiplications. So after closing multiplication, it will be volume of oxygen gas, it will be equal to 0.15 times 22.4 divided by 1. So up at the end, it will be, let's plug into the calculator, to be 0.15 times 22.4 divided by 1. So the volume of oxygen gas at STP, so volume of oxygen gas at STP, it will be 3.36 decimeter cubic. So this is the answer. Thank you. Let's continue and still following on this channel, so we will be together, and I will continue to deliver a sort of things that yourself it will be supportive for you. So don't forget to share, to comment, to subscribe. It's your chance now. Thank you.